Okay, Ashish, your
Hmm.
I am now going to take your mock interview. Okay,
Hmm.
I will be asking some non-technical question and technical question. Okay,
Hmm.
then after we will have feedback session.
Okay.
All right. Okay. So just tell me yourself, something about yourself.
Yeah. Good afternoon, sir. I am Ashish. I'm from my hometown is Gokarna. I live in Bangalore, and I have completed my 10th in Darshini Composite High School and PUC in Sharda PU College. And I completed my graduation in Gokte Institute of Technology with 8.48 CGPA. And I stay with my dad and my brother. My dad is a retired bank manager, and my brother works in a HCL technology as a design engineer. And my hobbies are playing cricket and listening to music. And I spend my free time with reading some spiritual books and listening to some devotional songs.
Which was the last spiritual book you read?
I read Yaduvanathan Nada Krishna, that related to Krishna.
Can you tell me some five learning from that book?
File learning, uh, Krishna will always tells that you have to always focus on your work, and you should not get emotional attachment with anything in a materialistic world, like that. And it's all related to the and later it is all related to war and something like that only.
It's only three.
Yeah.
I told you five.
And uh, I don't remember suddenly actually now.
All right. All right. So why do you want to join Merchant Navy?
Merchant Navy, I wanted to join because I can. Uh,
I can what?
Wait, 1 second. Uh, what because I know how to manage the pressure, and I know how to um, deal with the pressure situation, because before I have been working in an engineering without borders. I have organized the functions. I have organized the function, and I have also organized the projects also, and also I dealt with an academics at the same time, because of that I know how to deal with the pressure situation, and how to manage. And I hate to delay the things, means like I always believe in completing the work in time. So because of that I hate to listen that my work is not completed in time. So whenever I organized the EWI, till now I didn't hear anything related to my work, because work got delayed before time, like that. So I think that because this attitude of mine will help in the merchant navy also, so that I will never disappoint. I will do justice to the seniors under whom I am working with. Because of that, I feel that I deserve to be in a merchant navy.
Okay. What is your biggest fear?
My biggest fear is uh, uh, being idle is the biggest fear. Actually, without any work, and being idle is the biggest fear of mine.
Hmm.
I want to do some work, and I have also always want to do something. I don't want to be idle.
Okay. What is your strength?
My strength, it is the same thing that what I have told earlier. Why I want to join the merchant navy, because I have organized the organized so many functions, and so many at the same time completed the project and academic also. So I think
भाई
that
उनसे ये पूछना
I
कि
can
उनको
deal
मेल
with the
आए हैं
pressure
क्या जो
situation, and
राहुल रोल किए थे
I
क्या
can
पक्का
complete the
है
work
नहीं
in time.
या
So that is
दोबारा
my
आए हैं?
biggest
एक
strength,
बार पूछ
because
लेते
I
हैं
am
उनको,
always
ठीक
goal
है?
oriented.
Okay. Since you know this job is not 9 to 5 job, you have to be very far from your family. You have to be lonely. and for the longer period of time. So how you gonna tackle that?
I always do the one thing at a time. So when I am when I am doing the work, I will give my 100%. So because of that, I don't think that I will think about anything else. So because I am focused enough over my work, so I don't think I will feel lonely or anything like that. I can deal with it easily with an ease because before also in the college time I have stayed in the hostel only, so I have an experience of that. So I don't think I will be lonely, and there also so many crew members will be there. I will
तेरे
make
पे
a
कोई
new
लिस्ट
friends
आया है क्या
actually.
क्रोमा का? तूने भेजा नहीं अभी तक मुझे. So Ashish,
uh,
you when you passed out?
2020.
2020. So what you were doing since 3 years?
I was actually preparing for the IES because I wanted to join the railways very badly. So in between, because of some events happened in my home, because in between my studies, my mother got expired actually. Because of that, I can and in a home situation to deal with a home situation, I didn't properly focused on the studies, and later in 2022 I was preparing very well for an IES, but IRMS has shifted. They told that they will take only from an IAS. So again, to study the IAS, the syllabus is completely different from IES, non-technical with respect to non-technical subjects, and also with respect to overall syllabus also. So because of that, I dropped the plan. So that is what happened in my 2 years actually.
Oh, all right. Okay. So why you changed your mind from IAS to Merchant Navy?
After the IES, my relative, two far distant relatives are in the merchant navy only. So I happened to meet them after maybe on November or December, and they are well placed in one of the relative is in the passed out from an IMS Goa, and another is working in a fleet ship management of the Switzerland company in the merchant navy only. I really got inspired, and I happened to talk with them also. They are doing very well with them and with respect to
भाई
family
मैं
also,
अभी ज्वाइन
and
नहीं कर
earn
पाऊंगा
so
इसमें.
much of the
इसमें
respect in
किसने
the
मेरा नाम
society,
19 अप्रैल को डेट ऑफ ज्वाइनिंग
and
रखी है?
also they become more disciplined
मैं जून में
and
ही
become
ज्वाइन कर
more
पाऊंगा आफ्टर माय एग्जाम.
more punctual, and they have when
जून
I
में
talk
ज्वाइन
to
करना
them,
चाहता
I realized that if you
भाई
work
मैं
hard,
जून में ज्वाइन करना
if you
चाहता
give
हूँ.
100%
इसमें जो है
100% and
ऐसा क्यों?
nothing else, and if your
इसमें
attitude to
19 अप्रैल
learn
लिखवा
is
दिया
very
है
much,
भाई.
then
जून
sky is
लिखवा
the
देगा
limit
क्या?
in this field.
जून के
So
बाद, एग्जाम
that
के बाद.
has really inspired me. So I also and motivated me to join the
भाई
merchant navy.
इसमें जून लिखवा देगा क्या? ओके. सो आशीष,
Yes.
you are a spiritual person,
Kind of.
like you do meditate.
Yeah, sometimes.
You meditate, okay. What is the meaning of meditation for you?
Meaning of the meditation is, in my
भाई डेट ऑफ
opinion, it is
ज्वाइनिंग मेरा
just
जून करवा
practicing
देगा क्या?
the
एग्जाम
one thing at
के
a
बाद
time, and
ज्वाइनिंग करूँगा.
concentrating on the breath, and making the free of every tension and everything, every negative things from the mind, and focusing on only on one thing. So that is the practicing. The concentration is basically a meditation, I feel, in my opinion.
Concentration, okay. How many types of meditation you know about?
I know I have learnt the Shambhavi Mahamudra, and the normal in the only I know one, the Shambhavi Mahamudra.
Okay, what is that?
It is a exercise only which involves the breathing practices and it is basically only the breathing practices and the preparatory asanas are there. There is some butterfly asanas and another is uh, I, I don't remember the name, but I know the process how to how to do.
Okay. So you are from South.
Yeah.
What is the finest culture of South you like?
Finest culture of the south. There are basically, when compared to the north, there are so many temples in the south, and I didn't happen to go to the north actually. So I do. In the south, the culture is there are so many spiritual places, and there are so many visiting spots like Western Ghats are there, and there are so many sightseeings. The beaches also is there. All the three. South India is surrounded by the three beaches: Bay of Bengal, Indian Ocean, and Arabian Sea. And there are so many hill stations also there. So culture, in the sense, it is the same everywhere. Means like there are everywhere there are people and different kinds of people. So that's what I can
Okay.
conclude.
So have you visited North any time?
When I am very small, there was a family trip for Darjeeling, Gangtok, and Sikkim, Kolkata. Only once I have.
Okay. All right. So let's move to the next technical part.
Hmm. Okay.
Okay. So different. Tell me the difference between centrifugal pump and positive displacement pump.
Centrifugal pump is a rotodynamic pump. Positive displacement pump is based on a positive displacement action only. And as the viscosity of the centrifugal pump increases, the discharge decreases. And in positive displacement pump, discharge decreases because of the internal clearance between the impeller and the casing. And efficiency is affected by the pressure in the centrifugal pump. And efficiency is going to remain constant and increase with the pressure, and load increases as the discharge increases in centrifugal pump. In this, the load increases with increase in pressure in a positive displacement pump. And there is a high volume and the less. Whenever we require the high volume and less pressure head, we will use the centrifugal pump. Whenever we require the less volume and the high head, we use the positive displacement pump. And discharge is going to remain constant with pressure in the case of centrifugal pump. And discharge will changes with respect to pressure in centrifugal pump, and discharge is going to remain constant with pressure in the positive displacement pump.
Okay. In centrifugal pump, what is constant? Discharge or pressure?
So in both are not constant, because discharge and pressure also varies with electricity which we will give, and voltage and electricity will be varying. It is discharge and pressure is dependent on the electricity power which we are giving. So both will not remain constant, and because voltage current will be varying constantly. So
All right. Uh, so what is screw pump?
It is a, I will tell. There will be a two rotor, means two screws will be entangled with each other, and as we rotate the driver screw, as both the screws are entangled, the driven follower screw will also be rotated, and as it will suck the oil. It will As it will suck the oil, it will get transported to the discharge, and in the discharge the area will be decreases and pressure will be increases. So screw pump mainly used for the this sludge, to transfer the sludge. Sludge basically means it is a used oil. whenever oil is already used, there a sludge will be there. To transport that from the inlet to the discharge, we will use the screw pump. And to increase the volume of the screw pump, we will single screw, double screw, triple screw we will use to increase the volume.
Just wait for a second. Na?
Okay.
Rakesh, are you there?
Yeah,
You can carry on with the technical questions. Okay, and regarding pumps, I am just sending you the PDF also. Okay, all right.
sure, sure.
Okay.
Till now, how it is there? My performance.
It's more than good, but one advice for you is just try to improve that question. Why do you want to join the merchant navy?
Okay.
Okay, just focus on that because it is the first most question. So
First.
because it is the first most question,
Okay.
so you have to be very clear about that.
And when the video is not there, I am very comfortable to answer. Whenever video comes, I will get nervous. I don't know why.
Just focus on the camera of the laptop. Don't see in the screen because
Yeah,
if you see people around there, then you will get nervous.
yeah. Because unknown people know I will get a little. I'm
Yeah.
little introvert like that. So I don't know because of that.
Okay, just let me ask you a question. What is cavitation?
You on the video only because tomorrow they will come, no? So it's better to.
You have
Yeah. That is cavitation, right?
wait a second.
Yeah.
Wait. Yeah, what is cavitation?
When the pressure of the water which is sucked from the source is enters into the casing, if the pressure of the water decreases below the vapor pressure, the this cavity below the vapor pressure, water starts boiling and the bubbles will be formed. So that is basically a cavitation.
You said that bubbles will form. At which side that bubbles formed?
In the
The
suction side.
discharge side or the suction? Okay.
Suction side.
How we can control the cavitation?
Cavitation can be controlled by the decreasing the temperature of the source water. That is one kind, and NPSH of the NPSH of the pump should be greater than the NPSH of the required. Required is given by the manufacturer of the pump. It has to be more than that. Then the cavitation can be controlled. And the third way of the controlling the cavitation is there. I can remember only two.
Okay.
Is there any more cavitation?
Yeah, you can increase the suction level of the fluid. Okay, by
Suction level.
decrease. Yeah, suction level of the fluid.
Suction head. Another 3 pointer NPSH H atmospheric minus the head of the water level. By decreasing the head of the water level, also we can control cavitation. And minus vapor pressure.
So, tell me what is NPSH?
NPSH is a net positive suction head. It is also called as net positive suction head. It is the measurement so that the NPSH of the fluid from where the source from the where the pump is sucking the fluid, it has to be greater than the required one. So by doing that, the cavitation can be controlled. Definition I created on my own only, but I don't know if it's correct.
Okay. You said that vapor pressure. It is lower than the vapor pressure. So, what do you mean by vapor pressure?
Vapor pressure is the pressure below which the cavitation occurs. Means if the water is sucked and if the pressure of the water is greater than the vapor pressure, it has to be greater than the vapor pressure. If it is less than the vapor pressure, then the cavitation will occur.
Just define what is vapor pressure.
Okay. Vapor pressure. It is vapor pressure is the pressure corresponding to the saturated temperature, and if the pressure of the fluid is below that, then the boiling will occur.
Okay. Explain, bro. Explain gear pump.
Okay, gear pump. When the in a suction first gear pump is driven by driven, there will be a two gears basically. One is a driver gear and another is a driven gear. In the driver gear, the power is supplied to the driver gear. As the driver gear rotates, the it will in the suction side, as the suddenly the area increases, the pressure will be decreased, and there is an impeller. There will be the viscous seal between the impeller and the casing. Because of that, more suction pressure is created inside the gear casing. So the fluid will be sucked inside and it will be transported to the discharge. There will be a fine clearance between the driver gear and the casing. So in between the fine clearance, the oil lube oil will be transported from the suction to the discharge. And in the discharge, as the gear will be continuously rotating, the positive displacement of the gear will be taken place, because irrespective of the variation in the discharge pressure, the flow will be remain constant. So continuously the fluid will be transported from the suction to the discharge. Uh, and in a discharge side, there is a relief valve. If there is anything a problem, or anything the problem occurs in the discharge side of the pump, as it is a positive displacement pump, the pressure will be continuously increasing. So so there is a relief valve is set. So beyond that pressure, the pressure will be released, so that there is no bursting of the pipe should take place.
Okay.
Is it correct? Means like proper whatever I explained?
Yeah, you explained very well, but try to keep it as short. Okay. And just don't mention so many technical words. They may ask you questions about that.
Okay. Means how much should I, means like where should I, means what should I cut? Means like
It's okay. Okay.
Huh?
Just you have learned, it is okay.
Okay.
No need to cut and record.
Okay.
Let me open your PDF.
Hmm.
Just send it me.
क्या फील हो रहा है और बताया कि विश्व लोगों ने कि वहाँ को जब हम गए थे तब ना राहुल या बहुत आदमी का साले पहुंच गए और पता तक नहीं चला मेरा वो भूल गया था.
What is priming?
Priming is basically the removing the air from the case from the casing. That is called as priming. Removal the priming. There will be a priming port above the centrifugal pump, and removing the air from the centrifugal pump casing is called as a priming.
Okay. Do you know what are the methods of priming?
There are two methods. One is a manual priming, and another is the another one name I am not able to remember. Vacuum priming.
Okay, what is vacuum method? Do you know?
Means there will be a feed pump. Manual priming means removing the air and putting back the water. But in this another one vacuum priming, only the air will be removed out. That much only. I don't remember properly. Sorry.
Okay.
What is that? Means, can you explain? Means, what is vacuum?
मैं जब भेजा तभी पता चला ना तुझे.
Just a second.
Okay.
Okay. It is basically there is a vacuum pump fitted in the discharge side.
Okay, okay.
So as it sucks the air from the pump, so negative pressure is created inside that. Due to that, the low pressure is created now.
Yes,
So
yes.
due to that, water starts sucking easily from the sump. So
Huh.
that's how the we can suck the air from. Okay.
Okay. Another one, automatic priming is also there will be there. No, means only
Another one is that manual method is there. No?
manual method, and another one is there. Means like only automatic. Means like as the fluid is sucked, the automatically the air will be removed at the simultaneously something like.
So there is the air separation method.
Yeah.
Okay, so it's better don't mention that.
नहीं नहीं मैं
He's going
जा ही नहीं
to,
रहा
if
वहाँ
you ask him that
बिजनेस
air
सेंटर के पास
separation
क्या
method
हूँ
is there,
नीचे मैं
definitely he is
तुम्हारा ही
going to
बोलूंगा
ask you
कि मैं और सर
what is
रुके
air separation method. So
Okay.
better on the safe side, just
अच्छा
ask
ठीक है मैं
only
अपना
to that
Okay.
manual
अगर
method
मेरे से
and the
बात
vacuum
होगा तो
method.
Mechanism.
मैं अपना बताऊंगा ठीक है बाकी तेरे
Okay, what happen if the air is present in the centrifugal pump?
If the air is present in a centrifugal pump, it cannot transport the water anymore, because assume that the water in the form of the bricks, and air is density of the air is the density of the water is 1,000 times the density of the air. So as long as the when the water as water is incompressible and air is compressible, and when the impeller will strikes the air cannot move the water.
भाई मेरा 3
Because
राउंड
of
अभी
that,
तक नहीं हुआ
there will be a dry running of the pump will be taken place, and after some time, eventually there will be a burning of the all the windings of the motor will be pump gets starts heating up, and the winding will also gets heated up, and it can damage. You can damage the winding also.
Okay. So basically, it is the role of density, right?
It is the role of density, yes. And also,
That,
if the air is there, it cannot suck the water also, because the less negative pressure is created inside the pump. Because of the suction capacity of the pump will get decreased.
हाँ मैं
That's
फिर
also
right.
another reason.
So
अरे लौड़ा
Answer is
why
proper,
we?
right? Means like that answer.
Yeah, yeah. Okay. The next question is why we don't do the
अभी
priming in
मीटिंग
the
चल रहा है साला
reciprocating pumps.
Yeah, priming is not required in a reciprocating pump, because the suction of the water is taken place by the piston cylinder arrangement. Because as the crank rotates, the piston will be reciprocating. Because the piston is reciprocating, there is no requirement of the priming.
अरे मैं तो 1 सालों का घंटा मैं बस साथ में चला गया और आधे पंप पीछे का पंप कर रहा है
What are the effects by the cavitations? Like,
If
yeah, go ahead.
if there is a cavitation, then there will be a pitting of the impeller will be taken place, and because of that there is a deterioration of the impeller also, as the cavitation is taking the boiling will be take place, then mainly the impeller will get damaged, and eventually the pump will also get damaged because of cavitation.
Okay.
And if air enters, then less negative pressure will be created, and because of that, the suction capacity and also will be affected.
Okay, you can add into that there is if the impeller gets affected, then there is so much vibrations in that.
Vibration also.
Okay.
Okay, vibration is there. Then the flow or the pressure gets reduced due to the
Yes.
cavitations.
Why
Okay.
always impeller blade is always backward curved?
Backward curve, because in a backward curve, the more velocity or more kinetic energy can be created in the if impeller is backward. Means it means less than 90 degrees.
Like what it is doing?
Increases the velocity of the fluid, and increases the kinetic energy of the fluid, and
How
if the
the
kinetic
shape
energy.
decide the kinetic energy of the fluid? What is exactly it is doing to increase the centrifugal kinetic energy? You are saying kinetic energy or centrifugal force?
Centrifugal force also it increases, and it will
How does
increases
it
the
increasing?
velocity.
Like what it is doing actually? What
Because it exactly is doing that more area, it is giving the more area for the fluid. Because of that, more volume of the water can be pumped, means like more water can be moved outwards, centrifugal force can be applied on the water. So because of that, the backward vein is given.
all right. Oh, okay. So uh, explain VCR.
VCRS.
Yes.
Okay. Vapor compression refrigeration cycle. It from the compressor there will be a from the low pressure low temperature. It is the refrigerant is pumped to the high pressure and high temperature superheated steam. Then the reciprocating compressor is used, and then from the high pressure high temperature there will be a condensation. It moves to the condenser where the 30 degree Celsius sea water will be sent, and 40 degree it will be leaving in the condenser. Because of that, the vapor
Wait.
superheated steam is
All
converted.
right. Okay. Uh, what is the temperature of evaporator coil there?
Temperature of the evaporator will be minus 18 degrees Celsius to minus 13 degrees Celsius in the inlet side of the evaporator.
An outlet side?
Outlet side, as it is heated, no, there is a latent heat of vaporization takes place in the it depends outlet side of the it depends on the refrigerant we will use.
Okay, correct. Okay. Uh, so, uh, why compressor using of compressor is necessary in VCR cycle?
The using of the compressor is necessary because it converts the high pressure low pressure low temperature of the refrigerant of the vapor refrigerant to the high pressure and high temperature refrigerant. Because of that, there high pressure and high temperature when we convert. After that we can convert into liquid refrigerant again. So if we don't use the compressor, if you don't increase the pressure and the temperature, the vapor refrigerant cannot be converted back to the liquid refrigerant. So this is the main reason why we use the compressor.
Okay, which type of process does compressor does?
Compressor adiabatic process will be taking place in the compressor.
Adiabatic process. What is
Yes.
adiabatic process?
Constant heat, it will maintains the constant heat. For constant heat, by maintaining the constant heat, the temperature and the pressure will be increased. So that is the adiabatic
Constant
process.
heat. Constant.
Constant heat
Oh,
process.
all right. Constant, but
And
constant heat is only in isenthalpic process. You mean it is isenthalpic process?
no, isenthalpic process is the isothermal temperature will be constant in the isenthalpic process.
In then what is the difference between isenthalpic and isothermal?
Isothermal, not adiabatic. I think you are meant to say.
Okay, okay.
No, isenthalpic and isothermal.
Difference, yeah.
Okay, isenthalpic process in that the temperature will be constant only in an ideal gas, and the real gas in the real gas pressure and temperature also will be remain constant. In isothermal, the only temperature will remain constant in all the irrespective of the whether the gas is real or the ideal.
Okay. So temperature constant. In
Yeah,
isothermal.
in a ideal gas,
Okay. So
it will be temperature
let's
will
come to
remain
the process
constant.
of compressor. You said
Okay.
constant heat. Okay.
Adiabatic
Did you
process.
mean that the heat enthalpy of the refrigerant is not going to increase in compressor?
Yeah, enthalpy also increases because the
What do you mean by
compressor.
constant heat process?
Constant heat process means the process will be taking very fast. That is the what it is meant by adiabatic process. In adiabatic process, the process will take so fast that there will be no increase of the heat. Means like yeah, I assume that there is a candle, and and you light up the candle, and there is a finger. You put fastly like this, you will not feel any heat in your finger. So that is how the adiabatic, what I meant by adiabatic process.
Then
So when the
what is the
huh?
difference between adiabatic process and isentropic process?
adiabatic process and isentropic process will be remain same only in the case of the reversible process. In a irreversible process, adiabatic and isentropic process will be adiabatic process is not the isentropic process. You can say that all the isentropic process is an adiabatic process, but all the adiabatic process is not an isentropic process.
Okay, so in compressor, what is this reversible or irreversible adiabatic process?
In a compressor, it is an adiabatic process only. It is not an isentropic process.
Reversible or irreversible adiabatic process? Listen
Uh,
carefully.
I it is an I think it is irreversible process because 100% of the cannot be reversed. So it is an irreversible process.
But you are speaking wrong. Only reversible adiabatic process is known as isentropic process, and compressor is
Yeah,
an isentropic process. Why you are saying
compressor
that
is
irreversible adiabatic? If it is irreversible adiabatic, how come it is isentropic process?
compressor is an adiabatic process, right? It is an
It's a
isentropic. Yeah.
reversible adiabatic process.
Okay,
Reversible,
okay.
also known as
Then it is an isentropic process. Yeah, then it is a reversible then. I think that there will be some because for an the property of an it's reversible is it should be 100% friction resistance and so many assumptions are there. I am not sure that whether it is meeting all the assumptions. So I thought that it might be an irreversible process.
okay, isentropic process is a reversible adiabatic process. Cross check
Yes,
after
yes.
going this. Okay, and
Yeah,
okay, reversible.
it's
All right,
correct.
okay. So you were saying that constant heat in adiabatic process, but the definition, if you go by the definition, no heat enters or leak in the system is known as adiabatic process.
Yeah.
That what you mean?
Adiabatic. If it is an
It means Q
reversible
equal to
adiabatic.
0. It means Q equal to 0.
Yeah.
Does Q equal to 0 is equal to Q equal to constant?
No.
Then how you supposed to say it's a constant heat process?
The
In
Q equal to
adiabatic,
0.
are you going to agree this or not? In adiabatic, Q equal to 0.
The del Q is equal to 0.
Del Q or Q equal
Del
to 0?
Q. No, delta Q is equal to 0. Means Q1 minus Q2 means del Q is constant. Heat is
It's
constant, right?
Q only 0. No del Q.
Q equal to 0.
Q equal to
Okay,
0.
okay.
There is
Uh-huh.
no thing such like constant Q equal to 0. No heat enters or leaks. No heat enters or leak.
Okay, okay.
Q equal to 0.
Huh.
Okay. Q equal to 0. Oh, all right. So Rakesh, you can carry on with your questions.
What is the function of thermostatic expansion valve in BCRS?
Thermostatic expansion valve, it will controls the refrigerant flow inside the evaporator, and the thermostatic expansion valve, it will converts from a high pressure high temperature refrigerant to the low pressure low temperature refrigerant. These are the two functions. And there is a small hole in between, so as the velocity increases the pressure will be decreases. Because of that, temperature will also decreases. In entry and exit of the thermostatic valve, there will be a small hole. There will be a refrigerant flow will takes place through the small holes. So this is what happens. So this is the thermostatic expansion.
Does thermostatic expansion valve is a reversible process?
Temperature.
Thermostatic expansion valve is an irreversible process.
Irreversible. Highly irreversible. Okay.
Irreversible.
Okay. Why if you have seen the graph between the pressure and the enthalpy, okay,
Mhm.
you must
Mhm.
have seen the process of expansion valve is in
Is a dotted line.
why?
Because we are as it is an irreversible process, we don't know that how exactly the process will take place, so it is an dotted
Correct,
line.
correct, correct. So
Huh?
talking about heat exchanger, what is heat exchanger?
Uh, Heat exchanger is a device where we will one side we will be sending the required refrigerant or something, and another side we will be sending the cold water. Means like to reduce or increase the temperature, we will use the heat exchanger. Actually, I'm not exactly. I don't recall the
Okay.
this one
Uh,
definition.
uh, can we say that condenser and evaporator are heat exchangers?
No.
Hmm. All right. What do you mean by Bernoulli theorem? What is Bernoulli theorem?
Bernoulli theorem, the total energy will remain constant in an inlet and exit side. That is the pressure head, kinetic head, and potential head is going to remain constant. That is the Bernoulli theorem.
Assumption of Bernoulli theorem.
Fluid has to flow. It has to be inviscid, incompressible fluid, and it should be in a same stream. It has to be streamlined flow, and it has to be streamlined flow, inviscid, incompressible fluid flow. Only Bernoulli theorem can be applied.
Fluid should be ideal or not?
Ideal fluid, yeah, it is to be ideal.
Air is ideal.
It is assumed to be ideal.
Why?
Because
It is compressible.
uh, air is not compressible.
Air is not compressible.
Air is compressible. Sorry, air is compressible. Sorry. Air is compressible, and air is assumed to be ideal gas because pressure and
Does in a case of fluid that is air can be
hmm,
applicable for in this we can apply Bernoulli theorem, Bernoulli principle or not?
in air.
In a case of fluid
Air.
that's supposed to be air.
No, you cannot apply Bernoulli theorem.
Do you ever heard that the aeroplane that flies on the Bernoulli principle?
Yeah, that is the different case because
Listen. Have you heard or not? Are you agree
yeah,
with me?
yeah,
So,
yes,
aeroplane flies in a fluid that is supposed to be air. Okay.
yes.
If air is not applicable for Bernoulli principle, uh, then how supposed to it is applying like this only? Just tell me the concept of flying in airplane. How
Aeroplane.
aeroplane flies?
Yeah, aeroplane. The wing is designed in a such a way that there will be a high pressure air is going to flow over the wings, and there will be because of that the pressure difference, their natural lift is going to take place. That concept we can apply in an. I think the concept of the Bernoullis can be applied, but you cannot apply the Bernoulli formula in that. I don't know. I am not sure. I guess I don't know.
If you are not
I'm
sure,
just
that
a
just
guess.
say no, na. Why are you
Yes.
explaining false? Okay.
Yeah.
If I explain you, uh, tell me if you agree or not. I am saying that for flying a airplane, Bernoulli principle works. Okay,
Yes.
okay. Suppose air is this is a wing of plane. Okay,
Hmm. Hmm.
wings is made such that the upper part of air have low pressure, generated low pressure, and the lower part of that wing generates high pressure. Like
Hmm.
is moved such that you have heard moving air will create a low pressure,
Yeah.
increasing velocity will create a low pressure, is moved such
Yeah.
that the upper part creates low pressure, lower part creates high pressure, and you know
Yes.
move fluid moves from low pressure to high pressure, so
Yes.
it lifts. Okay,
Yeah.
wing is such like made such that only. Okay,
Yes.
you are getting me.
Yeah, I got it.
Just you said that air is fluid, but only if it is moving with high velocity.
Oh.
Air is like air can be ideal fluid. It can follow
Huh.
the Bernoulli's principle. Air can behave
Huh.
like ideal fluid The condition is it should be moving with high velocity. In a case of
Okay, okay.
aeroplane, it moves with very high velocity, so that's why
Ha,
it
ha.
creates a
Low
like
pressure.
moving with high velocity.
Yeah, yeah. I got it.
Air moving with high velocity will act as a ideal fluid and
And
follow.
ideal gas condition is also the it ideal. Any gas can follow the ideal gas principle only when pressure decreases and low pressure and high temperature.
Low
So
pressure.
because it is air is moving with a high velocity, pressure will be low. So it can be ideal gas. It can be
Yeah,
assumed
that
as ideal
you
gas.
are going in deep, that we have studied in the concept. That is very good that you
Yeah.
know about that. But before that, I had asked one question, that exchanger, heat exchanger, does evaporator and condenser are heat exchanger or not?
No, it is not a heat exchanger.
Rakesh, tell him.
Yeah. Can you just repeat the question?
Okay, okay. Does evaporator and condenser are heat exchangers or not?
This question was asked in
Yeah.
interview.
Basically, they are heat exchanger because they are exchanging the heat. In condenser,
Heat
yeah.
is being rejected. In
After the
evaporator,
compressor,
heat
we
is
have
being
the
rejected.
high heat, na, high temperature.
Ha,
You got
I
it?
am not very
No,
sure
no,
about it.
you explained very correctly. That it is a heat exchanges. What condenser does? It exchanges heat. It rejects heat to the atmosphere.
yeah, yeah.
What the evaporator does? It accepts heat from the
Yeah, it is.
Ha,
atmosphere.
yeah,
It
yeah.
is not heat exchanging. It is heat exchanging. In evaporator, you
Hmm.
have heard there is a coil, condenser coil, evaporator coil. That coil is what? It's a shape of it, nothing but heat exchanger. So
Okay,
this
okay.
can be the reason of your rejection. Oh, this is a
Yes.
very basic. Bernoulli
Yeah,
theorem,
yeah.
how the aeroplane flies.
Hmm.
You didn't explain. You like this can be the reason of your rejection. Okay. So be
Okay, okay.
clear with your basics. Okay.
Okay,
And
okay.
in case of isentropic process, like in the case of adiabatic process, Q is
Okay.
zero, not constant. It's zero. Okay.
Q is 0.
Okay. All right. So,
Okay, Ashish, my
Ha,
last question is,
Rakesh, sir.
yes.
what are the refrigerant used on board?
For refrigerant, before we used to use the CFCs and all. Then after the MARPOL regulation on the 2020, now we are using the high HFCs, mainly HFCs. For example, 404A, 407 C, and R134A are the some of the refrigerant I can remember. We are using on board.
So why we are not using the CFCs now?
Because there is a high amount of the chlorine content or the fluorine content. Because of that, there is a pollution is going to take place. To avoid that pollution, the chlorine will combine with the moisture and it become the hydrochloric acid, and it can be reason for an acid rain. So because of that, no, sorry, it's sulfur. No, no, correct. So chlorine, more chlorine atom can deter. It can be a pollution. So because to avoid the pollution only, we will use the. We will not use that.
Okay, have you heard about the global warming potential?
Yeah, yeah.
What is that?
Global warming potential. Uh, I don't remember exactly, but I don't recall as of now. It is a trapping the carbon dioxide and carbon monoxide is trapping in the atmosphere. Because of there will be a global warming is taking place. So that is called as global warming potential because of the carbon and the carbon monoxide gas is trapped in between the in the ozone. So because of that, global warming is taking place.
Okay. Anurag, can you please turn off your camera?
Okay.
Huh?
Okay.
What?
Ashish, have you heard
Yes.
of greenhouse effect?
Yes.
What is that?
Greenhouse effect. it is also it is a trapping the pollution. It is a trapping the all the waste gases, carbon and carbon monoxide in the ozone layer, and it is increasing the temperature of the environment. That is called as greenhouse effect.
The how it is different from global warming? You said the
I think
same.
I said wrong in a global warming. It
The,
is greenhouse effect.
it is greenhouse effect. Okay. What is
Yeah.
ozone depletion?
I don't remember recall the definition exactly. So
Any idea about on a superficial level?
ozone depletion, I think because of the sun ray ozone, there is an holes in an ozone layer. Because of that, there is so many of the harmful sun rays will be entering into the environment. That is because of that there is a depletion is taking place on the ozone, and
It is
holes are
exactly
creating
no
of
need to
the
over explain. You right. It is exactly what is you are saying. Before saying that
yeah.
only you are giving up. Use your presence of mind in a junior
The
class.
definition I can't remember
What is the
exact
definition? The
definition.
Don't
concept
need
you
to
know.
explain the definition.
Okay, okay.
No need to. You know what is the ozone
Uh,
depletion? Is the depletion of ozone layer. Ozone layer is what the layer that is above the atmosphere. Okay,
hmm.
that protect us from the reaching ultraviolet rays to the
Harmful.
sun.
Yeah.
This is the thing.
Yeah.
Use presence of mind. What is global
Okay,
warming
okay.
potential? You know CO2 is the major factor in global warming potential.
Yeah, that time.
Carbon
Global warming.
footprint or these things. Due to the
Yeah, yeah.
increase of temperature of the earth, due to increase in
Huh.
the temperature, the amount of CO2 in the environment causing global warming. Global warming is
Yeah.
what? Warming of global.
Hmm.
Global is
And because of that,
increasing.
ice is melting in the and
That's
increase
only.
in the level of the seawater.
That's only.
That,
What is greenhouse effect? That the trapping of that heat.
trapping off that heat.
I also don't know, but we have
Huh.
heard something. Speak
Yeah.
something. Use presence of
Okay,
mind.
okay.
That's what you like. The the
Okay, okay.
portion you read, the explanation you gave of your prepared question
Hmm.
was awesome. Okay,
Hmm.
and this time
Okay.
you were so confident. Like
Yeah,
as
because
compared to
I don't feel nervous in front of you and all. The sir
see,
is taking, I feel nervous. I feel that he knows very
you don't
better,
know.
and if I miss something, I can be like
why
nervousness is
why
that.
are you feeling not nervous? Because you consider me as a friend. So
Yeah, yeah.
consider also. And if you know about myself, I also deal with the manager who is a millionaire billionaire in Delhi. Okay, to for
Okay.
exhibition mart.
Uh,
If they also consider like if you got to know about that I deals with the big people as a
mm,
marketing person or then you may got the image that Gyan do such thing. Gyan sit and sit up with the people's like
high five people.
high five people. Then see, it's all perception right here. You how you see that. Okay,
uh, yes.
that's why soft skill question are made up. Na soft skill question
Uh,
are there just to be relaxed. It's a
okay.
normal talking. Take
Mm-hmm.
interview as a next conversation.
Mm-hmm.
Okay, I am also telling myself, not only
Uh,
you, I am also conversation. See the profit where the profit lies. If you are taking interviewer as a very big deal, not a nervous, I'm making yourself nervous, or just just a chance that you are going to get selected, just a chance of express yourself. It's my best friend who is which is better thinking.
yeah.
So don't be nervous, yeah. See,
And compared to yesterday, now performance is good, right?
yeah,
It's
very
like
good.
Yeah,
It
exactly.
was very good. So what is indicator cock?
I don't means like that
You
I don't know properly.
you discuss with the Prince sir.
Yeah, but I at that time I didn't understood what he told me. It's like
What
I
he
know
generally told the same thing. Like use presence of mind. What is indicator cock? As the name
indicator cock.
as the names
Indicates
say something as the name
draw chord. It will draw the draw chord
you
because
are
in
you
the
are still explaining the wrong explanation. Indicator chord as the name suggests it's indicate it indicates the performance of the engine is
uh,
whatever it is.
okay.
It indicates the, it is an
Okay,
instrument that
indicates the
indicates
performance of
performance of engine,
uh,
output of engine, power of engine.
yeah.
Okay. So before using your presence of mind, I am not able to understand the things. That thing you are going to regret that I could have explained that.
Uh,
But if I would have, but
and
what
so
your
many answers now, which where I
no,
have answered, it is unprepared questions only like that.
so don't, it's not it's not your thing that I have, you are the one person who have prepared the largest number of questions and answers,
Yeah.
or you who have what. And
Mm-hmm.
so you made your mind that just just what I have prepared, that only going to come. Okay,
Mm-hmm.
it is not going to like that. It is not a
Okay.
question and answer session. It is a thing that you build yourself, build your personality from your childhood to this manhood, from your the no things have you. This also calculate your the early childhood experience, early childhood thing, greenhouse effect
Mm-hmm.
you have you aware. This is not so use presence of mind. Okay, it is
Mm-hmm.
not
Okay.
like that I have prepared some certain question or answer and I am going to speak
Mm-hmm.
only that. If he is asking
Mm-hmm.
like that, you have a structured question and answer, that is way better.
Mm-hmm.
But be prepared for that. So
Okay.
now explain, what is the concept behind you see the sky blue?
It is basically the Vibgyor. The Vibgyor means violet indigo because there is a high frequency, high wavelength of the light will be there in an violet indigo and Vibgyor and blue. So because of that, whenever the sun ray travel from the outer atmosphere to inner atmosphere, there will be a scattering of the light. Because of the scattering of the light, the wavelength of the violet, indigo, and blue is more. Because of that, we will see the blue color more in the atmosphere. That is the reason.
What? I didn't get it.
Wavelength of the wavelength of the violet, indigo, and blue color is more compared to the other color. Whenever the sunlight passes through the outer atmosphere, the scattering of the light will be taken place. So the wavelength, as the wavelength of the violet, indigo, blue is more, the scattering of the this blue light is
Wavelength
more.
of
So we will see.
violet indigo is more.
Uh,
What is the
yes,
wave?
sir.
Are you sure?
I don't know. Maybe frequency then. I don't know.
You know,
Mm.
putting a finger here and there shows you are underconfident.
Okay. Okay.
This for you, Harshit, also. This is the perfect gesture of the confidence. Okay,
Okay.
if you are like this, you are sitting with Prime Minister and dealing with him.
Hmm.
If you are like
Okay.
always, this is the gesture.
Jan, can I say something to Ashish?
Yeah, sure.
Ah,
That's why I you are
Okay.
in. Okay.
So Ashish, what I think that you know
ah,
everything. Like
ah,
what I think that you know everything, but you are not able to express it. You are
ah.
not able to deliver it. That's the problem.
Hmm.
And nothing will matter if you will know everything, but you are not able to express it. Your
Hmm.
knowledge is of no use if you are not able to express it. So
Yeah.
try to be expressive. Try to make your content in a structured manner.
Hmm.
Your
Okay.
Like it seems like you know everything, but you are speaking in a very haphazard way.
Ah.
So try
Okay.
to focus on that.
Okay. Okay. I will do. So I'm asking Gyan to conduct more mock interview so that I can be confident.
See, yaar, I have also na.
Yeah.
Okay, will do.
Yeah, I know that.
Where Rakesh will take,
Understand.
on a rotation. There are people,
Ah.
okay, who
Ah.
can. But see, until unless you are not going to use your presence of mind, na. Okay,
Hmm.
and I am slightly disagree with the Anurag. Okay, you
Hmm.
can't be prepared,
No,
systematic,
actually,
and
it's Harshit.
okay, it's Harshit, but your name is written Anurag. Okay,
Yes,
okay.
how can I change it? I want to change it.
Okay, later discuss. So I am
Okay.
slightly disagree with that for every question, and I think you have more structured question answer. Rakesh in the early thing, he explained very in a very structured manner the things he had already prepared. But the
Yeah.
question which is going, the question that is cross question. For in that you are lacking. Sometimes you are over
Hmm.
explaining, sometimes you are confusing yourself, sometimes.
Hmm.
So for that, use your presence of mind. Try to be structured while focusing. Like the concept
Okay.
you are giving in the that why we see, it is the same concept. But the thing
Ah.
you forget that the violet with your, that red is the biggest wavelength, and violet is having the biggest frequency. Since the
Ah.
violet and blue color vibgor, they are having the largest frequency, biggest frequency, so they scatter more.
Okay.
When they
Okay.
come in the atmosphere, they scatter more with the particles like which is present in atmosphere. That is
Ah.
nitrogen, oxygen.
Yeah. Yeah. Got it.
So
Got it.
they scatter more. So
Ah.
after scattering, they falls on our eyes. Since they scatter
Hmm.
more, so that's why we see
Hmm.
more blue or violet color, sky
Okay.
blue.
Okay.
You are getting me?
Yeah.
how
Ah.
l-
Got it.
how layman I am making it. Okay, at that
Yeah.
time I don't know, in a case of IS interview or PCS interview, doing like this is so much dramatic and can poke interviewer and can,
Ah.
but in a case of explaining some concept like physics concept or some technical concept, you can use your hands minor, that the light
Hmm.
strikes something like,
Hmm.
it is help,
Hmm.
it anyway it can help you. What do you think, Harshit?
Hmm.
Yes, I think if you are showing the gesture, it will help you to explain it well, and that
Okay.
will
Okay.
make you like a little bit attractive in front of the interviewer.
That you are
Ah.
more clear that. Okay, the thing,
Hmm. Hmm.
like if you are explaining Faraday's law of electromagnetic induction, just explain
Hmm.
Faraday's law of electromagnetic induction.
There is basically two laws. First law of the Faraday law is whenever EMF is linked with a circuit changes, there will be current will be induced, and current will be induced. The second law, the
Current will be
amount of
induced or EMF will be induced.
EMF will be induced. So EMF will be induced. Sorry, whenever whenever the wait. Whenever magnetic field is linked with a circuit changes, the EMF will be induced. And the second law is induced EMF is directly proportional to the change in the magnetic field. That these are the two laws.
Okay, now listen.
Uh,
Okay, for Faraday's law of electromagnetic induction
mhm.
basically defines or predicts the relationship between the electric field and the magnetic field,
Yeah,
circuit
yeah.
and magnetic circuit
Uh,
for an
yeah,
induction of electromotive force EMF. It
yeah,
consists of two laws. The first law
yeah.
states that whenever there is a relative motion between the
Uh,
electric circuit and the magnetic field, their their electromotive force EMF will be induced. And the
uh,
second law states that the EMF will be equal to the amount of magnetic flux that is linked with the conductor coil.
uh.
You got it?
Yeah, I got it.
It was which I explained. It was little basic or in a layman,
Yeah. But these two, what I explained, that is the exact wordings of the Faraday law.
but more conviction. Bring more
Yeah.
conviction. Okay.
Uh,
What is Lenz law? Hey, Harshit, Rakesh,
Yes,
Yeah.
which I explained was like was understandable or not?
it
Yeah,
was
it is
good.
understandable,
It
but
was good. It
if
won't
I am in the
understand.
case of Ashish, no, I would say the same as Ashish said
Yeah.
because I have
Can
the
I try
same
once?
definition.
Yes, Harshit.
Can I try once?
Yeah.
Can I try
I
once?
will be asking you
Okay.
the only these questions. Okay, you can try
Okay. Okay.
here. Okay, no problem.
Okay. So according to the Faraday's first law of electromagnetic induction, whenever a conductor is placed in a varying magnetic field, an EMF will induced, and likewise, if the conductor is of closed circuit type, then there will be a current also induced, and that current will be known as the induced current. And according to the second law of Faraday's, it states that the EMF that is induced because of the change in the magnetic field, it is directly proportional to the rate of change of flux.
Yeah, it's also okay. Harshit, it's also correct. Rakesh is also correct. What I found now, what I found after seeing that, when I was not understanding this concept, now I was just tipping this line from bookish language. Okay,
Mm-hmm.
but 2 3 days I actually understand what is that. That's why varying conductor field, ये फलाना डिमका, I just use whenever there is a relative motion between the electric circuit. Electric circuit is what? The conductor within moving within circuit. Okay, but
Yeah.
when there is a relative motion between circuit and magnetic field, there will be the induction of EMF. And the second law states that the induction of EMF will be equal to the amount of flux linkage with that conductor coil. Okay.
Hmm.
Now, at this time, okay. Now, tell me what is Lenz law.
Lens law, I don't remember the exact definition,
Are
but
you
I
going to
know.
say that to interviewer? I don't remember the exact definition.
No.
So why
Uh,
are you saying to me?
Ashish, try to think that you are in the actual interview. We are not your friends. We are the
okay.
actual
Okay.
interviewer. Okay,
Uh,
so act
okay.
like that.
Okay. The induced EMF will always it will always opposes it will be it is always opposes the field. I don't remember. Sorry, I didn't study.
Harshit, what is that?
Okay, so according to the Lenz law, the EMF that is induced because of the varying magnetic field opposes the cause of its cause. That is, it opposes the varying magnetic field.
What is Rakesh? Rakesh.
Basically, it opposes the cause of its production.
Now
Like
listen.
according to the Lenz law, the EMF induced in such a way that it will oppose the cause of its production.
Okay. Now, if I have to explain, I would have explained like this. Okay.
Go ahead.
Just if I would have to explain, I would have explained like this only. That am I audible? Oh,
Yeah.
all right. So I would have explained that due to the varying magnetic field, there will be the induction of EMF in conductor coil. Okay, and due to this induction of EMF in conductor coil, there will be also induction of magnetic field. As we know, when current flows, then it will have magnetic field also, and the direction of this magnetic field will be in the opposite direction of the existing magnetic field. This much only. Yeah, it you can put this on also like this. If due to flow of current in the electric circuit, there will be the induction of magnetic field, and the direction of that magnetic field will be the opposite, will be opposing in the direction of the existing magnetic field. Like, it is nothing but a third law of third interpretation of Faraday's law of electromagnetic induction. From there only we get the negative sign, that is EMF equal to minus and d phi by dt. Okay. Ashish, you are muted.
Yeah,
See,
yeah, I got
literally
it.
what Rakesh, I let me put my point of view honestly, causing the causing the opposite, like causing the, what was the line that is very
The
confusing,
cause oppose
opposing
the
the
cause
cause
of
of
its
its,
production.
opposing the cause relative
Yeah, this one.
it was, it had choked me earlier very time whenever people say like
Hmm.
book is, अरे भैया हिंदी में जा रहा हूँ, अगर मैग्नेटिक फील्ड रिलेटिव मोशन से पहले हम इलेक्ट्रिक सर्किट में कंडक्टर, डोंट डू लाइक दिस.
Huh.
ओके. इलेक्ट्रिक मोशन इलेक्ट्रिक सर्किट में हम करंट पैदा कर रहे हैं. अब जब करंट पैदा कर रहे हैं तो हमें पता है कि जब करंट कहीं फ्लो होता है उसका मैग्नेटिक फील्ड भी होता है. उस मैग्नेटिक फील्ड का डायरेक्शन बताने के लिए लेंस आया. उस मैग्नेटिक फील्ड
Hmm.
का डायरेक्शन ये होगा कि जो एग्जिस्टिंग मैग्नेटिक फील्ड है जिसके वजह से वो करंट पैदा हो रहा है उसके अपोजिट होगा, तभी हम कहते हैं दैट इट्स अपोजिट द कॉज ऑफ इट्स
Uh,
Production.
cause of its production. Simple. Lenz law states that the current flow in the circuit will have the magnetic field, will have induced magnetic field that will be in the opposite direction of the existing magnetic field, by which the varying magnetic field creates the induced EMF, जो भी जोड़ना है जोड़ना।
hmm.
ठीक है। मेरा
Very well.
स्ट्रेटेजी क्या है कि मैं बहुत लेमेन रखूंगा, बहुत बेसिक रखूंगा। ठीक है।
उसके लिए मेरे को फिर से पढ़ना पड़ेगा इलेक्ट्रिक।
कन्विक्शन। मैं इलेक्ट्रिसिटी में दिमाग खराब हो गया था मेरा, दुनिया भर का अपोजिंग द कॉजिंग द। कल परसों जाके मुझे पता चला कि यार माजरा ये है, इतना सिंपल था कि इलेक्ट्रिसिटी जब इलेक्ट्रिक करंट पैदा कर रहा है तो उसके पास मैग्नेटिक फील्ड होगा। बस उस मैग्नेटिक फील्ड का डायरेक्शन बताने के लिए इतना यही लेंस लॉ है। आर यू गेटिंग मी हर्षित? सो हर्षित,
Yes, I'm getting you. That's right.
all right. So I think I will have I am just winding it off. Okay. Uh,
Okay.
so Ashish,
Yes.
suppose I am not selecting you.
Ah.
Suppose you are not getting mail tomorrow.
Hmm.
What would be your reaction?
I will be a little disappointed, and later life moves on.
What?
I will be little disappointed that in spite of doing hard work, I'm not getting selected, and then I will see some alternative and see some other college also. I will try to apply.
But you are not going to give up in this career.
No.
What if you are not destined to be go in the merchant navy? Will you be going to live your remaining life in a depressed mode?
What? What is?
What if it is
Question.
not destined to
हाँ
be
हाँ
go to you to go in this field? So
हाँ.
you are going to live your remaining life in a depressed mode? Are you
No.
you won't feel any kind of depression? Are you sure as a human?
Uh,
How are you robot?
no, not like that. Means I will just focus on the other work so that I will not be remembered of much energy. If I remember, I will get disappointed later.
So how it is not possible that you will not remember this anytime.
Yeah,
Yeah, yeah. This was the
yeah,
dream
I
you have
remember.
built in your
I will just
heart.
get distracted.
This was the dream you have built in your heart from the last 2 3 years. Okay.
Hmm.
So how you are going to remember from the till the day of your death? So
Yeah,
and every time you can't do any other work to forget it. Is it the way you are going to live that?
I can build an analogy. If you have a girlfriend right now, and if you marry someone else, then after marrying some other girl, you will be depressed that you don't married that previous girl. In the same way, like that, you will just focus on the other
No,
one.
try not to give this example. Just try.
No, I just I will not give this example actually. I just gave an
Thank
example.
God you didn't said I am used to it. I will let it go. I will let it go.
Same thing only I told in another way.
Okay, okay. All right. No problem. It was right. Okay. So you got your feedback that everything is fine, but the thing, okay, and maintain your posture. Don't be lean.
Okay, okay.
Don't. ठीक है? What I do,
Take your body
what we do,
and
what,
don't your fingers put on your face.
yeah.
The main thing.
Yeah. I don't know that it will
No, no, no.
just go like
Be
that.
that posture, okay?
Yeah,
And
yeah, yeah.
what we do now, sometimes my bad habit also. I am just my leg, playing with my leg, okay?
Hmm.
I
So
think Ashish, that is because of your beard and mustache. I think you should like trim it or
Yeah,
remove it.
I will
I
remove
think that is
it.
why you are putting your hand again and
okay,
again on
Yeah,
the
yeah,
mouth.
okay, and
yeah. I will.
also put a formal and formal that is
Yeah.
uh, bend like here only.
Full covering.
Full
Yes, yes.
covering now, half covering.
Huh? Okay.
This is
Uh,
a summer, okay?
yeah.
Okay, all right. And see, what I do while talking, I just what is that meaning, yeah? Shiver my leg,
Shaking your legs,
shaking your leg.
shivering or
See
shaking
the
your legs.
shaking your leg, presence of mind,
Mm.
shaking, and
But
while
Jan,
shaking,
this thing looks very bad when you are on the stage.
yeah, na. See, it's looking bad, na.
But this thing will look very bad when you are on the stage. Like right now, it's looking fine because you are still sitting.
No, no.
But
See,
if you will be on
it
the stage,
while sitting also, when I see my other interview while sitting also, I don't realize that I am looking bad. But while sitting also, it giving me it giving the wrong sense. It is not good. See, my
yes,
head is
yes, yes. And also according to our rituals, it is like a bad omen to shake your
मामा
legs.
खो जाएंगे हमारे.
Yes.
ठीक है. That's only.
Nice one.
So
Uh,
Ashish, we will be.
yes.
I am going to put a recording off. Okay.
Okay.
Then we'll start with the uh, how
Uh,
is it